Okay, welcome back to this tutoring session going over this worksheet. Because we expressed some issues with problems number 19 and 20, I'm going to go ahead and work on a video that works with questions 18 through 21 because they seem to be similar in nature. So I don't spend too much time on this video, let's go ahead and get started. So this, even though they all say problem number 1, this is actually number 17. So let's make sure we look at that, and I probably should have adjusted this already so I don't waste your time. But there we are, number 17. And can please write. Okay. Number 17. And it obviously did not do what I wanted it to do. Number 17. Okay, so now, 1 minute into this. If we're looking at a compound as a percent composition of this, what is its empirical formula? And then it has a second question, what is its molecular formula if it has a molar mass of 148.16 AMU? So the key idea here is to first answer this first question. And when you're given something in percentage, what you're going to want to do is convert that to the composition or to its empirical formula by taking the percentage and assuming that you have 100 grams. So what I can say is I have 100 grams of this substance, whatever it is, and we just know that it's made up of carbon, hydrogen, and oxygen. So 48.64%, if we have 100 grams of the entire composition and 48.64% is carbon, that means you would have 48.64 grams of carbon. And that also means that you would have 8.16 grams of hydrogen. And that also means that you would have 43.20 grams of oxygen. If we add all these up, we have 100 grams. And so that makes that nice. Now, the next thing you want to do with this information is you want to convert them all to moles. So this is just a simple mole conversion, and we went over that in problems number 1 through 10. And so we know the molar mass of carbon, moles of carbon, and we know that 12 grams is equal to 1 mole. And then we know that 1 gram of hydrogen is equal to 1 mole of hydrogen. And then we know that 16 grams of oxygen is equal to 1 mole of oxygen. So now we simply use our handy dandy calculator. Of course, I'm getting these values from our handy dandy periodic table, and so just look at your periodic table to know where I'm getting 12, 16, and 1. You can see those there, but I don't think that's anything new or riveting that I need to go over. So 48.64 divided by 12, we should be getting like 4.05. So it's 4.05 moles of carbon. Here, surprisingly enough, and I'm going to do this one in my head because I'm gifted at multiplying divided by 1, it's going to be 8.16 moles of hydrogen. And in this one, we have 43.20 divided by 16. We get 2.7. Now, all of these are different values. Sometimes you're going to encounter where they are all the same, where one of them is, or two of them are the same and one is different, or they could all be the same. But in any case, you take the lowest of these values and you divide them into the others. So what is my lowest value here? You guessed it, 2.7. So I divide everything by 2.7. And here I will get a 1. Here I get 8.17 divided by 2, or 2.7. Here I get something really close to 3. And if I divide this by 2.7, I'm probably going to get a fraction. Obviously, that's going to be the case. 4.05 divided by 2.07, or sorry, 2.7. And we get 1.5. That's a fraction. That kind of makes things a little more complicated, but not too tough. So our ratio of carbon to hydrogen to oxygen is 1.5 to 3 to 1. All right, so what does that mean? We have carbon 1.5, hydrogen 3, oxygen 1. Now, I cannot express a formula with a fraction, with a 1.5. So I got to get rid of that 1.5 or that 0.5 off of there. I do this, if I multiply something by 2, by 0.5 by 2, I will get a whole number, which will give me C3H6O2. And that's my empirical formula. So I've answered problem number 1 on that, all right, or the first question in there. Now it wants to know if the compound's formula mass is 148.16 ANU, what is its molecular formula? So in order to do that, I have to figure out first the molar mass of my empirical formula. So my molar mass, and sorry about my handwriting, it's never going to be good on here. And we have carbon, we have 3 times 12. We have hydrogen, we have 6 times 1. And we have oxygen, which is 2 times 16. All right. So we have 36, 6, and 32 for a total of 8. No, sorry. That's 12, 14, 74 grams is the molar mass of my empirical formula. So why do I need to know that? And that is because I'm trying to find my molecular formula. And my molecular formula has a molar mass of 148.16. All right, so I'm going to take my molar mass of molecular and divide by molar mass of empirical. So what I have is, and I can't remember that number to save my life, sorry to waste your time, but it is 148.16. 148.16 divided by 74, and that's going to be close enough to 2. 148.16 divided by 74, which is exactly really close to 2. So we're going to say that it is 2. What do I do with that 2? I take that 2 and I multiply that times my empirical formula, so I would get C6H12O4, and that is my molecular formula. And I got that because I took the molar mass of my molecular formula, which was provided, divided by the molar mass of my empirical formula, which we found in the first question. We found the empirical formula, then we found the molar mass, and we divided that into that, and we got a factor of 2, so we just simply multiply the empirical formula by 2 to get the molecular formula. And there you go. Now, question number 2, or question number, I don't know what this is, 18, or 19 rather. This was kind of confusing to me for a second, but a lot of times this question is asked, what is the percentage of one of those elements in the compound? They want to know the percentage composition of the entire thing. So what you do is you just break it down. And this can be broken down into barium, chlorine, and oxygen, right? So that's what we have to do. We have to just break this down into barium, chlorine, and oxygen. And this is simple enough. Just look at the molar mass. So what do? We take barium. How many barium do we have in here? We have 1. What's the molar mass of barium? I don't know off the top of my head. 137 maybe. 137.33. 137. And that's 137 grams. And chlorine, we have 2 times 1, so 2 times 35.5. So we got 71 grams. And then we have oxygen is 6 times 16, right? And that should be something really close to 96 grams. Now, what's the total molar mass? We add all that up. 96 plus 71 plus 137, and we get 304 grams. That is not the answer. The answer is, what is the percent composition of each, all right? Or that's what I'm interpreting anyway. So for barium, the percent composition is going to be the 137 grams that the barium is contributing divided by the total mass of the entire compound, which is 304. And then you're going to multiply that times 100%. So what you get is 137 divided by 304 and times 100, and you get like 45.06%. So 45.06%. Now, the next part is doing the same thing. 71 grams of the chlorine divided by the total mass of the compound. And 71 divided by 304 times 100. You get 23.35%, something really close to that. And then lastly, you can do the same thing, or you can figure out add these two up and subtract from 100. Either way, because you're going to total up to be 100%. But easy enough to just say 96 divided by 304, and whatever we get there, 96 divided by 304, and you get about 31.5%. 31.5%. And that's as simple as that is. Moving on to the next one. The next question, it says, what is the percent of calcium in a compound if 25 grams of the compound contains 6.52 grams of calcium? Well, this problem is even easier than the last one. So if you already know that you have 6.52 grams of calcium and the total mass of the compound is 25 grams, you're just doing the one step that we did in the last problem. So what is 6.52 divided by 25? And then we have to also not forget that we have to multiply this times 100 to get our percentage. So 6.52 divided by 25 times 100, and you get 26.08%. So that was easy. And then lastly, these empirical formulas, probably didn't need to go over this one with you, but you find the lowest number and see if there's anything common. We have a 2 to 10 to 4 ratio. It could be broken down to what is 2 divided by 2? It's 1. 2 into 10 is 5. H5, whoops. And then 2 into 4 is, so my empirical formula is C2H5O1, or O. In this case, 10 into 22, what's a common factor? Well, it is 2, right? So we have C5H11. And then this one, it's ionic. It's already the lowest. See, these are molecular. You have nonmetals exclusively. Here you have this metal, barium, with this nonmetal or polyatomic ion. Every time you see one of these, it's its empirical formula. It's in this lowest whole number ratio. And you get that because your sum of your charges are equaling 0, and so they automatically become the lowest whole number ratio. So this is already its empirical formula. Anytime you have an ionic compound, know it's its empirical formula. I hope this video helped, and thank you very much.